Welcome back. This is the last lecture of week 1. While we are going to learn a lot of theoretical algorithmic concepts in testing, ultimate goal in testing is to be able to design a test case yourself and try to execute it. So for that you need tools, you need test automation support, and there's one very popular, well used open source tool called JUnit, which I will teach you through this example. As we move down the course in subsequent weeks, as and when we learn various kinds of testing, various algorithms for test case design, wherever relevant, you can try to design those test cases using the algorithms and execute them using a tool like JUnit. I'll walk you through the basics, then I'll share the website of JUnit, tell you what it's all about, and you will get to do assignments through the course wherever that is relevant using JUnit. A lot of this learning on JUnit is practical in nature, where you learn by solving questions and by experimenting yourself. What I'll be doing today now is just a theoretical overview of what JUnit is. So after we've designed test cases and we are ready to execute your test cases, you need support with automating the execution. So that process is called test automation. So test automation, remember, test case needs to go to a particular place if you're going to test a particular fragment of code, and whatever that particular fragment of code outputs need to propagate to the output, and so on. So this is what we learnt as RIPR criteria in one of the earlier lectures. So the way we do RIPR in test automation is to give what we call prefix values and postfix values. Prefix, as the name says, helps you to reach the fragment of code that you're trying to test. Postfix values will ensure that the output of the fragment of code that you're trying to test, those values do propagate and end up in the software producing the output. So as a summary definition, test automation is the process of controlling the execution of tests, comparing the actual outputs produced by the software to the expected outputs that you had written as a test case designer, setting up these prefix values, postfix values, other ways of reporting, and so on. This entire process is test automation. So remember what we saw as a test case? We said simply test case was inputs and expected outputs. If the actual outputs match the expected outputs, we say the test case had passed, otherwise the test case had failed. Now, in addition to that, suppose the code that you're testing is embedded somewhere deep inside the overall software that you have, you need to give prefix values and postfix values. So let's see what they are. Prefix values are basically the inputs that are necessary to put the software into an appropriate state so as to be able to receive the test case values. The other extreme is postfix. Postfix values are inputs that have to be sent to the software after the test case is sent to make sure that the remaining portion of the code gets executed and the output is produced. So they could be verification values, which are values needed to see the result of the test case execution, or they could be simple exit values which ensure that the execution completes and the program terminates normally. So a test case that is ready for execution, unlike a test case algorithmically, includes the following: the actual values of the test case, prefix values and postfix values as necessary, and expected results or outputs that are necessary to complete the execution and evaluation of your module under test. When I get a executable test script, the test case is prepared in a form that can be executed automatically on the software, and a report can be produced about the test case passing or failing. So JUnit is a tool that will help you to do this. It's an open source testing framework for Java. It can be used to write, design, and run automated tests, and this whole process can be repeated several times. We will specifically look at JUnit, But corresponding unit testing frameworks exist for several other programming languages. So JUnit is an instance of what we call an XUnit architecture. X could represent some other programming language instead of J for Java, and it represents a generic test execution automation framework for unit testing. JUnit is itself available as an open source tool from junit.org. Towards the end, we'll open the website and walk you through that. It's basically a structure for writing test drivers. JUnit can be used to test standalone Java programs from your command line, or it can be used within IDEs like Eclipse, IntelliJ, NetBeans, Jupyter Notebook, Visual Studio Code, and so on. So JUnit has several features. This is just a snapshot of some of the important features. One of the core features of JUnit is the notion of assertions. Assertions help you to write whether, if I do a test case execution, what would I expect as a result of that execution? We'll see several examples of how to write different kinds of assertions. It's basically like a Boolean predicate that will return true or false. In addition to that, JUnit will support several different test features for sharing common test data and test inputs. It also supports test suites for easily organizing and running tests, and it has, as I told you, graphical textual test runners, and it can run from within an IDE. So tests in JUnit can be used to write test cases for testing an entire object, a part of an object like a method or some methods with their call interfaces, or it can also be used to test for interaction between several different objects. It's primarily used at the level of unit testing and integration testing, typically not for system level functional or non-functional testing. You need some other tools for that. Each test in JUnit is embedded into what we call a test method, and test methods are organized, grouped into a test class. A test class includes a collection of test methods that can be used to set up the state before and update the state after each test executes, or sometimes after all the tests execute. So how do I write test cases for JUnit? There is a particular class called junit.framework.asset. Based on your IDE, the name of this class could be different. Use the methods of this class. Each such test method will contain an assertion, which is basically, as I told you, a predicate or a condition that returns a Boolean value, and it will report to the test runner about whether the test case is failed or succeeded. You could write various kinds of assertions to check for yourself whether a particular test case has succeeded or failed. Test runner, as I told you, is basically used to report the results to the tester or the user. All the methods in JUnit will return void. For example, I could write something like this. This is one kind of assertion. I say assert true, a predicate or an expression that returns a Boolean value. So this, for example, could mean if a function is supposed to add, then you pass two arguments for addition for that function and check if it returns the correct value as the result of those addition. And if it does, then this Boolean value that the assert true will return will be true. So the whole test case passes. Otherwise, the Boolean value that this assert would return would be false, and then you can infer that the test case fails. You could also add some comments to such an assert true. So you say if this Boolean value evaluates to be true, then you print an argument like the string as output. Like for example, you could say test case has passed as the string to say that the assert is returned correctly the value, or you could say addition is happening correctly. It's just a comment that you add to which will be displayed in the console obviously as a tester to understand whether the assertion is passed or failed. This is another kind of assertion. So it just says fail. It means that if something fails, then you output this string, output a message that the string contains. We'll see some examples as we move on. The other things are test fixtures in JUnit. A test fixture, as I told you, helps you reach the place that you want to test and come out of the place that you want to test. So it is basically the state corresponding to a test. It includes objects, all the variables that are used by the tests that you're considering. Typically not one, we write more than one tests. It includes the prefix values which are used for initializations. It includes the postfix values which are used for reset. Different tests can use the object without sharing a state. Objects used in text fixtures should be declared as instance variables. They should be initialized. There are two kinds of methods, several others. This is just a sample. One is before each and the other is at before all. This is for the prefix, and for the postfix or reset values, you do at after each or at after all. Here's a small toy example, as I told you just a little while ago. Suppose we've written this calculator program which has a method for addition, and it takes two integers and returns the sum. So this is the program. How do I write a test case in JUnit for this? The current version of JUnit, as you would see in the website shortly towards the end of this lecture, supports JUnit's integration with Jupyter. So I have picked up this from that website. So you will have to do this. You will have to call this assertions, particularly assert equal. This calculator is available in your utils. And this is the thing, this thing for Jupyter, and this is the class, and then you say calculator is this, and then you write this method called addTest. So what does it do? It basically says pass values 2 and 3 to this method called calculator.add and check if it returns 5. If it works correctly, it should return 5, and so the result of this output will be equal to 5. Then assert equal will say, okay, these two values are equal, so the test case is passed. This assert equal will fail, will return false if the actual output is not 5 when I pass 2 and 3, in which case you say that the test case is failed, and it could indicate that the method that is used for addition in calculator could be a wrong method. Similarly, another example to walk you through how to use assertions. Let's say I have to compute the minimum of a set of numbers. So then first I import these things. This is not specific to Jupyter Notebook, general imports. Each could vary based on the IDE that you use. And then you write your prefix and postfix values. Prefix values could be written like this. It's an array list. Postfix values just says tear down, which is called after every test method. So here is a test case for checking for minimum that uses the fail assertion. So it says list is null, it's a try catch exception, and it says the minimum is the minimum of list. And if it's null, then it will say you fail because null pointer exception was expected and that didn't happen. So this is an example of how a fail assertion is used. Similarly, suppose I pass an empty element and compute minimum for that. Here is a test case that will say I expected a null pointer exception class, and this is how the test looks like. So you can go on writing different kinds of tests. We'll see more examples directly from the website. You can also write data-driven tests. What do I mean by data-driven test is, suppose you wanted to test calculator like we saw earlier. That simple test that we wrote just passed two values, one test case that has two values, 2 and 3, and it checked for 5. Maybe you would want to, as a curious tester, test it for some more value. If it adds any number to 0, will it return the same number? Can it add negative numbers correctly? Things like that. So you might want to pass a set of test cases to the same method simultaneously without writing each time elaborate things. So that's what we call data-driven tests. They basically, in JUnit, they call a constructor for each collection of test values, and then the tests are run for each set of these test cases, and then a result is produced. So we will see how to do it. So we've highlighted what we've done now is I've just got you started on JUnit, just the basics of it. We've highlighted certain features towards illustrating its use in test automation. Remember, it's a full-fledged tool that is up to date, and it has several other automation features. Even though it's open source, it's used widely in the industry. So what I'll do now is, let's go to the website of JUnit and I'll walk you through what it has. So this is JUnit. Currently the version that is up and running is the 5th version, as it says. It's for Java, but you could pick up the same thing for other test cases. So let's go down. There are these main things in the website. So I would like to walk you briefly through parts of this user guide. So this is the user guide. If you see, the entire table of contents is here. It's a fairly large user guide. It tells you what JUnit 5 is all about. JUnit 5 is actually JUnit as a basic platform plus JUnit for Jupyter notebooks and JUnit Vintage, which basically shows backward compatibility. If you had or used or are familiar with using earlier versions of JUnit, you could do this. So it has several different, I encourage you all to read through this website. Unfortunately, we will not be able to go through line by line of this website, but you can write several projects. So this is the thing that I told you about. Suppose you had to write a test case in JUnit. This is exactly what we saw in the slides. Right? I had passed 2 and 3. Here they have passed 1 and 1 and checked if it is equal to 2. So this is like a first small test case that you could write for yourself using JUnit. This assumes that you're using Jupyter. If you want to use Visual Studio or Eclipse, down this page you will know how to write the same test case for that framework. Instructors also have a whole set of interesting assignments which will help you to do this. You could write simple annotations. JUnit supports several kinds of annotations for configuring and extending their framework. @test is what we saw. Basically denotes that a method is test method. You could have @parameterized test, repeated tests when you want to do regression testing. You could have a test factory, test template, so on and so forth. Several different things are there. I briefly told you about these methods. @before each, @before all, @after each, and @after all. Remember that these are used for our RIPR criteria. @before each or @before all tells you what should be run before you reach the main portion of the code that you want to test. @after each and @after all tells you what to run after you finishing executing the main portion of your test. So several other annotations are there. And then comes this, so let's move on to test classes and methods. So as I told you, @test was one thing, then what else is there? So here is a standard example of a test class. So this is again specific to Jupyter Notebook. Later in the same website, you will see how to write it for Eclipse or Visual Studio or IntelliJ IDEA. So you have to import the respective methods, the respective classes. And this is the standard test. So @before all, @before each, @test, @test that succeeds and fails with a fail assertion that we saw. @test can be used in several different versions like skipping, aborting a test. Then after each and after all are the postfix or the tear down methods that we saw. Then you have display names, like for example, as I told you, right, you might want to print something and in fact you can print a whole set of things. How do you do that? Like you write like this. So test classes and test methods can declare custom display names via this @display name. You can do all kinds of things. You can do simple things like this, custom test name containing spaces, and write it like this. You could put some complex special characters like this. You could even write emojis like this, whatever you want. Then, so there are several kinds of display name generators, and let's move on to assertions, which are important part of learning how to program with a tool like JUnit. As I told you, assertions form the core intelligence of JUnit, and you do the same functionality that you want to do using several different kinds of assertions. So here, for example, there is assert all, assert equals, assert not null, assert throws, assert timeout, timeout preemptively, assert true. This is still a sample. The whole library of asserts are there. And this code will tell you how to add. So this standard assertions uses assert equal. So it says if you call the function for addition in the calculator and pass it 1 and 1, it should return 2. If you call the function again multiply in the calculator and pass it 2 and 2, it should return 4. And similarly, if you say is A less than B, then you say that assert true is possible. Similarly, you can group assertions. Like for example, you could say Jane, you could say Doe, first name, get last name. You could have dependent assertions, what is happening, starts with, ends with. You could use assertion for testing exceptions like division by 0. You could use assertions for testing for timeouts, various kinds of timeouts. You could use assertions just to write your first hello world JUnit program also. Right? So that was the part about assertions. Please go through it. I'm just walking through it quickly. And for different languages, they have different kinds of assertion supports. The next important thing that I would like to highlight in this website is that JUnit also has support for what we call conditional test execution. So this is an API which helps you to enable something, to disable something. So let's say you want to focus on a part that you want to test. So you disable all the parts that you're not interested in. Or you want to focus on the part that you want to test. So you enable some extra features of the parts that you want to test, and so on. So these kinds of conditional test executions are possible in JUnit. Like for example, suppose you want to test something to work only on the Mac operating system, or something to work only on Windows or Linux, something to work only on a certain kind of architecture, other kinds of processors, and so on and so forth. You could write several different kinds of conditions. This is only for Java runtime environment, Java 8, Java 9, whatever, Java 9 to 11, 8 to 11, you could do these kinds of stuff. You could check for system level properties. Please don't misunderstand this to be used as system this thing, but it's for testing on a particular kind of system, not for system level testing. So you could do these kind of conditional testing. The next thing that I would like to highlight is down below here. Like we said, data-driven tests, JUnit can be used to do parameterized tests. Same thing, run multiple tests with different arguments and put them all inside your regular test method using this parameterized tests. Like for example, something like this. I could say I want to check if a particular string is a palindrome. So I pass 3 inputs simultaneously. One input is race car, one input is radar, and the other input is the string with spaces. And you say assert true, is it palindrome for this candidate? And it will pass these candidates one at a time, and then here is the result. So it says all 3 are palindrome. So it passed. So race car is a palindrome, radar is a palindrome, and then this string that you see is also a palindrome. So you could do a whole set of parameterized tests like this, and this section 2.16 down on the left here lets you walk through various ways of doing parameterized tests. Finally, one last bit, I am skipping through a few sections hoping that you would read them. On running tests. As I told you, this page is updated for JUnit 5, which works with Jupyter. But let's say you use some other IDE. If you use Intel IDEA, this is how you would run tests. There is help available. If you use Eclipse or JetBeans or Visual Studio, refer to the corresponding sections. Help is available for several other IDEs also. So that was a brief introduction to JUnit. Go through these and as and when necessary, obviously not all together, and familiarize yourself with how are you going to use various features of JUnit down the course to run your test cases. Okay, so now we saw JUnit's features. What next? As I told you, whatever test cases we are going to execute in JUnit, somebody has to design them. If you ask yourself where do they come from, it comes because test case design it has to happen. Test case design happens because you have a goal in mind, you have a test requirement in mind, you know what to test, and one way of specifying it to say this is your criteria for testing. So that's what this course is going to be all about. It's going to be all about your criteria for testing. So I'll stop here for now, and I'll see you all in the next lecture. Thank you.